everyone, today we are going to discuss today's daily challenge, that is longest common subsequence. It's a very common question and a very known DP problem. It's a good problem to be aware of and it will definitely help you in your interviews. So let me explain you what is the requirement and what exactly can we do. So I'll try to provide you a very generic solution which can be implemented very easily rather than something that you have to cramp up at the end of the day. Okay, so see what it is saying, that you are given some text 1 and some text 2. Okay, both of them are string and you have to just tell how many common subsequences, how many common characters are there in the same sequence. That's all you have to tell, and whatever is the longest common subsequence that you find, return that. So in here you can see A and A were common, right? C and C were common, E and E were common, so we will return 3. Similarly, if we see these, all these 3 values are common on and in the same sequence, so we'll return 3 again. And in here we can see that there is no common value, so we'll return 0. So if you see a pattern, what is happening, A, B, C, D, E is there, correct? And A, C and E is there. So initially our I and J will be at this point, right? You will say, is this and this character same? See, this is what we are doing over here, right? We are checking if both the characters are same. Assume that yes, this is a valid character, correct? And just assume that you will add this value to your final sum. Now your task is to find that for the remaining string, how long of a subsequence I can get, and if I get a final value from these subsequence, I can just add 1 to it, knowing that I have already got the value that is associated with these substrings. Now I just need to add 1 to make it a final answer, right? That's what we are doing. We are adding 1, assuming that the current characters can be picked up, and for the rest of the characters I have just increased my I and increased my J, and I'll continuously do this until and unless one of them reaches to the end, correct? That's what we are saying, that if any one of them reaches the end, then we will return 0. There is nothing else to compare, correct? Now the second thing you might ask, what if the characters do not match? Here it matched, fine, but what if it doesn't match? Okay, fine, let's discuss on that as well. Let me remove this entire thing and let's pick this example again. A, B, C, D, E, correct? And A, C, E. Initially our I and J were at this point, right? This was my I, this was my J. Both of them were same, so we assume that okay, we are good to go. You can increase your I and increase your J and let me know what is the solution that you are getting. I'll just add 1 to it. But over here you see that these two values are now not equal. Now we are inside an else condition. Now what we can assume, that fine, maybe this B is okay, but this C is irrelevant, or the C is something which is causing the issue. In that case, what we will do, we will say, do one thing, just increment your J and let I be where it is right now. Okay. Or the second situation could be, this C is at correct position, but this B is causing the issue. In that case, what we will do, increment your I and let J be at the position where it is right now, correct? That's what we are doing. If you see carefully over here, that's what we are doing. We are not incrementing our I at one scenario, and in the second scenario we are not incrementing our J. And then we are saying, now tell me, now in here let's talk about this condition where we are saying B is relevant. That means this string is still valid, but the C is irrelevant. Now the string or the substring have been replaced by B, C, D, E and E, correct? And in the second scenario, this B will get ignored and our substring will be this and this. Okay. So that's what we are doing, that okay, if I assume that one of the character is irrelevant, let it be, let's remove it. And now tell me, out of these two situation, if I take any one of this, if I either take B, C, D, E and E, or C, D, E, C, E. If I take any one of these, what is the maximum common subsequent I can get? Whatever is the maximum one, I'll say that okay, taking this will make more profit, or taking this will make more profit, and accordingly we will save that value inside my temporary integer value. Okay, once we get the value, correct, once we get the value, our task will only be to find the value which we will be getting from picking up the value and not picking up the value, correct. We can just whatever two values that we have till now, pick and not pick, we will pick it up, and whatever it is, we will return that value. That should be enough. Okay, now the second situation that occurs is, what if, as you can see, there can be some overlapping subproblems as well. You discovered B, C, D, E and E, right? Now let's suppose you are at this point and you are at this point and you decided that you will discard B. Okay, in that condition, what problem you will receive? You will receive a problem B, C, D, E and E, correct. This is the problem that you will receive. And if you look carefully, this is something that you have already solved. So if you observe it carefully, it does contain overlapping subproblems, correct. In that condition, that's why we are using a DP array. So a task is that whenever I'm getting my final answer, I'll just save it inside my DP of ij. Why I'm doing that? Because in the future, if I discover the combination of I and j again, if I discover this combination again, I can just ask that, are you not equals to -1? If you are not equals to -1, that means you have already been discovered and you already have the longest common subsequence within you. So just return that. Do not go and recalculate everything again and again, otherwise it will cause TLE. That's what we are doing. Fine. So that's all the code. We are making sure that if any one of them reaches to the end of the string, we'll return 0. If a particular I and j combination is already visited, then we will return the value that we have saved. That's what DP is for. That's what memorization is for. People make DP so complicated, but in reality, if you see it carefully, I was able to run this particular code without these lines as well. If I remove these line, this line, this line, this line, and this part, if I remove all 4 lines, I will still be able to run this code perfectly. It will just cause a TLE because of this overlapping subproblems, right? So for that, we just involved or introduced a DP, which we will be saving our value and which we will make sure that if that particular value is already visited, then we will return the value that is stored within it. That's all DP is about. People make it so complicated and people think it's too hard, but in reality it is not. Okay, so this is a DP solution, correct. And as discussed, we will call different DFS calls based on our I and j combination. In the end, whatever is my solution, I will save it in my DP of ij. Fine. That's all the code is about. Let's quickly discuss about the time and space complexity. Let's see. Here, what is happening, for each combination of I, you are either picking up that value or you are moving forward, correct? In the worst case, you are moving forward. For this one, for the next I, again you have to go through all the combinations that are present, correct? So can we say that for each I, the number of I's that I have plus this will be equal to, for each I have to go ahead and check for the other remaining values of my j, correct? So it will be I cross j, where I is equal to length of text 1 and j is equal to length of text 2. Fine, that will be my time complexity over here. I can't see anything else that is causing the issue. If there is any overlapping subproblem, that is already solved, already added in DP, so it will not cause any extra time complexity. If we talk about space complexity, then definitely we are again using I cross j or text1.length into text2.length as my DP size, so that will be included in my space complexity. And I'm also using a BFS call which will have a stack space as well, right? And in the worst case, this stack space can go till O of the size of my text 1 or text 2. So assuming text 1 is greater than text 2 or both of them are same, so I'll say that this time complexity will be of I plus whatever was used for my DP array, that is this. So this is my space and time complexity. Hope it helped. Thank you so much.